Hi there, this is Mr. Nash with review of Unit 2 of AP Physics 1, which is dynamics. What's dynamics again? Oh yeah, forces, basically. What is the background information that you need to know? Well, sorry, knocked down my water bottle, didn't want it to spill. F equals ma. Force equals mass times acceleration. Some of the forces, if you want to say. And that is Newton's second law. That is the very most important thing in this unit, and really, it's really important in all of physics. That's very important. But sometimes it equals 0 too. Remember why? If you have a constant velocity equals 0 acceleration equals, that means that the forces equal 0. The sum of the forces, at least. I don't know how to write that thumb thing. Just pretend that's that Greek letter. Okay, so another thing is the force of friction. By the way, what are the forces that there are? Well, I mean, there's other forces that are not in this unit, but in this unit, there's mostly just normal force. What's that thing? Something that's just a natural force that makes something up. So it's like something that's the opposite of gravity. Why don't I just go through the floor? Because of a normal force. Force of gravity, that's what brings you down. It's not the same thing as G, because force of gravity equals mg cosine theta if there's an angle. And there's also friction force. Why can't something just go crazy and smash through everything? Like if I slide this water bottle, you can't really see it, but it's like, why doesn't it just go across the room? Because friction. There's a push force if I push on something. There's a air resistance force too. What's the other one? Oh, tension. If there's like a rope or string. There's also spring force too, and what's the other one? There's a centripetal force, which you never put on a free body diagram, by the way. Very important. And what's the thing in Unit 7 that I'm thinking of? Well, that doesn't matter. That doesn't have to do with this unit necessarily. But anyways, friction force equals mu. Oh, what's that dumb thing? It is friction, like the degree of friction-y, whatever you would want to call it. And so what's the degree? And it's mu m. If mu is nothing, then there's no friction, because if it was 0, then it'd make the whole thing. But if it's the closer it is to 1, the more friction there is. So higher mu for grass than snow. But and it's that times the normal force, and the normal force is mg cosine theta. The gravity force is just mg, and you might say, and it can be mg sine theta when it's for the x, but we'll talk about that later. And the tension forces, you should set them equal to each other when you're solving. That's just what that means, and also the acceleration. And this is just an example. Like if you're trying to find a tension force by itself, you'd have to do the sum of the forces minus the tension force plus ma, and that's the same for any of them. And really the most important thing, well, not the most important, but a very important thing, is that positive is the direction of motion, not up, right. You might be like, oh, up positive, right positive. Not always. There could be some dumb problem where something's moving to the left. That means left is positive. Or something's moving down, that means down is positive. So let's start out by this. 1 Newton equals, well, that's kind of a vague question. By the way, I didn't make these questions. But it equals, if you remember, it is a kilogram times meters per second squared. Well, that kind of makes sense. Kilogram is for mass, meters per second squared is for acceleration, Newton is for force. That makes sense, doesn't it? Newton measures force, by the way. And what are the 3 Newton laws? And this example, don't care right now. All right, what's the first law? An object remains at rest or in motion until acted upon by another force. By the way, they won't really ask you to say the specific law, but they might say using a Newton's law, do this, like, so just saying. And the second law is sum of the forces equals mass times acceleration. And I know it's a Greek letter, but I'm not writing that right now. I don't know how to do that really. And then every action has an equal and opposite reaction. That's another thing. So if something that is super heavy and something that's super light, like mouse and water bottle, mouse is lighter than water bottle, they smash together, which one hits the other one with more force? Same. That's what Newton's third law says. Okay, what's the difference between kinetic and static friction? That's a good thing to know, but it's not really like, that's key of a thing. But kinetic is for when it's moving and static is for when it's at rest. So static is what does it take to get it moving? And kinetic is like, what does it take to make it stop? Kind of like that. And so there you go. That's kind of just some general questions, but let's look at some other examples. I'm not going to do all of these, but let's see here. Wait, is this? All right, let's look at number 10. Wait. Okay, so a block of weight W is pulled along a horizontal surface with a speed V by force F, which acts at an angle theta. What is the expression for the magnitude of the normal force? Equation, not a number answer. That's never what they're going to tell you. That's just because this was a teacher that made this. So, but that is true. So what is the magnitude of the normal force? Sorry. Well, how do we do this? How? Sum of the forces equals mass times acceleration. That's how we do it, because it's asking for a specific force. Now, constant speed. Always pay attention to that. That means acceleration is 0. By the way, why? Well, constant speed means a velocity graph would look like that or would look like that. And the slope of that is a constant number, meaning acceleration would just be a constant number, because the slope of velocity is acceleration. So acceleration would be 0. Oh, wait, what? I said something wrong, sorry. Constant, no, that is completely wrong, I'm sorry. Constant speed means that it is the same value, and it's like that, it doesn't have a slope, which means the slope of that is 0, so acceleration is 0, sorry. So that means this equals 0. Well, what forces do we have? Well, that's why it's good to do a free body diagram. Hold up. I'm confused here. Oh, sorry. I think, what I was looking at was not lining up with this. But anyways, free body diagram. So remember how to do those? So you draw a dot and then you say, what forces are there? Well, there's a force of gravity down as usual. That's always what there is. And then a normal force, there's always a normal force, but it's always directly up from the surface. It's not always just up. Like it could be like this if the surface was like this, but the surface is normal this time. So normal force is up. And so what other forces do we have? We have friction. Didn't say it was frictionless, so we have friction. And that's to the left. Why? Because it is pushed to the right. The velocity is to the right. So that also means that this is right is positive and up is positive. In this case, remember what I said. If this thing was being pushed to the left, then that would be different. In this case, up is positive and right is positive. And we have a force of it being pushed, and we can just call that or pulled, so that we can just do FP, and it's at an angle. So then what we do is we chart our forces to figure out which one is negative or positive. So the X forces, what's in the X? All right, we have FF, that is to the left, which is negative. Why? Because it's opposite of where the direction of motion is, which is to the right. And so that means FP is positive, but at an angle. So that means it's kind of going up and it's kind of going right. So we have to instead make this into two different FPs. We have a FPY for the one that goes up, which would be positive. And then we have a FPX, which is going to the right, which is also positive. So FPX is positive. And then we have a negative FG that's down. That's why it's negative. Well, that's not why it's negative, but whenever you have something that's just on a flat surface, up is positive and down is negative. Fn is positive, and then Fpy is also positive because it's up. So that took long enough. Well, now we need to put all of our forces together, but we're doing the normal force, and the normal force is in the y, and so we have to do some of the forces in the y only. We don't do all of them, only the y ones, because what we're asking for is a y1. So we do negative Fg plus Fn plus Fpy equals 0. Why 0? Remember, because of constant speed. And so you rearrange this in terms of Fn. That is, you would add the Fg, so it's positive, but then you subtract the Fpy, so it's negative. So this is what our answer is. So there you go. All right, now let me see. All right, now we're going to do one last one, and this is a crazy one, but let's just see what we have here. Two masses are attached by a rope that is threaded around the pulley as shown. Identify the four shown forces. Yeah, well, that's kind of a little bit different than what you usually do because it just says T. But let's just start out by this. So what would F1 be? Well, that looks like it's down. So what would bring it down? Its mass or its weight. Weight is the same thing as the force of gravity, which is mg. So that F1 would be Fg. What about F2? Well, that's like trying to keep it up. That's tension. And then what about F3, same thing, trying to keep it up. It's repelling it, and it's by a rope. And then same thing with like number 1, this would be the FG. Which two forces are equal? Why? The FTs. And I already told you that. You said they are equal to each other because it's on the same, in this case, it's because it's on the same rope. Same rope, same tension. So that's all, that's important. Same rope, same tension. And I already told you that, so I'm not saying why. Calculate F1. Okay, F1. Well, we're gonna have to use some of the forces. Oh wait, never mind. We don't have to do that. We can just say FG. What is FG is always mg, unless it's at an angle, but this is not at an angle. So the same thing for this one. We can just say mg. And the mass, what is the mass? 2 kilograms for that one. And what is the gravity? 10, and we make it positive because this is dynamics and not dumb kinematics. And so the answer is 20 newtons. And then we follow the same process for that one. You would do 8 times 10, which is 80 newtons. Which direction, which are y? All. If they're up or down, that means y, so all. So which are x? None. Which way will it accelerate? This is a dumb thing. I'm looking at this thing, this answer key thing, just to make sure I don't say the wrong thing on accident, but it answered it incorrectly, but whatever. Which way will it accelerate? Why? So it's basically meaning which way will it go when if they were just like let go all of a sudden. Well, what do you think? The heavier one, right? Like the lighter one won't come down. It's like the heavier one will. So you would say to the right. I mean, I don't know if that's the right way to say it. That's kind of a vague question, but let's just say that it's going to accelerate that way. Which force is bigger, F1 or F2? Why? F1 is the gravity, F2 is the tension. How do we know? So less than the FT. Well, this one, this answer thing says because the smaller mass is less than the FT. Well, for this one, you need to do, I don't know what that thing's saying, but you need to do the sum of the forces, which this does have acceleration. Okay, well, we're just going to skip these for now because I already showed you how to solve a specific force, but that's how you would do it. Remember, I just did that, but I'm just going to skip those for now because for time's sake, I already showed you that. But let's find the acceleration. Well, what do we know? We need to know, we know we're trying to find acceleration, so we do what equation we can use. That's this. If you solve in terms of A, that is the A equals sum of the forces divided by the mass. Which means what forces do we have? We have F. Well, let's just call this FG1. We'll call this FG2. We'll call this FT1. And we'll call this FT2. And what is positive? The direction of motion. The direction of motion is down. So this guy's positive. This guy's negative. This guy is positive because it's trying to go in the way of the motion. This guy is negative because it's trying to go the opposite. So, all right, we have negative FG1 plus positive FT1 minus negative, plus positive FG2 minus negative FT2. Divided by M. And then you might get stuck because you're like, hey, I don't know the tension forces. Well, guess what? Remember, they're the same. If you have a negative one and you have a positive one, then you can cross those out. Bye-bye. So now you do negative FG. Well, we already knew this force was 20. So negative 20 plus, and remember, we found out that one was 80, the other one. And you divide that by the mass. And we have to do the total mass, which, what is the total mass? 10 kilograms. So that is going to be 60 divided by 10. And just trying to speed this thing up. That is this. Done. Oh, great. What is the speed? See, sometimes you have to connect other units, kinematics. What is the speed of the, well, we don't really, the mass doesn't matter, it's just saying, after 4 seconds. So we're trying to find speed, what's the velocity? We're trying to find velocity. And then what equation do we use? We'll have to use the kinematic equation, but it has to be one that doesn't have distance in it. And that's all, the only one that doesn't have distance in it is this. And why? Because we don't know distance. And that would be the final velocity. The initial is 0. Acceleration is 6. We just found that in the other problem. And then this is 4, time is 4. So the velocity is 24 meters per second. That would be the end of this unit. Although, I wish that we had one that was talking about something that goes on a ramp. That's very important. Okay, so sorry that I said that was the last problem. I got to do one of those. That's very important. All right, a bicyclist. And we are just not going to, we're going to not do part B. We'll just do part A for time's sake. And a bicyclist, and hang on a second. I will just white out these, hang on. I'm going to white out these. Wait, hold up. That's not white. 4 colors. I thought that was white. Whatever. I'm just gonna cross out these things so that I can have more room to write. All right. Okay. So drawing a picture can be helpful. So there's a bicyclist that has a mass of 65 kg. And they go down a 6 degrees hill with acceleration of 2.3 meters per second squared. And we're trying to find the force of kinetic friction, which just really means force of friction. What is that? All right, so we already did for the acronym KFES, which I say commonly, what you know, what you need to find, we already did those. What equation did we use? Well, that should be pretty simple if you're trying to find a specific force. Sum of the forces equals mass times acceleration. Acceleration is not zero, so we don't make it zero. So, well, we need to know what forces it has, so let's draw the picture. So, or really free body diagram. Well, picture then free body diagram. So let's just say, okay, here's a biker. It's not letting me draw. Right, that's a terrible picture. Don't care. It's down a 6-degree angle, right? And they're going down it, right? Down. Okay. And now we do free body diagram. We have a gravity force down, always down. We have a normal force to an angle because the surface is at an angle. We have friction backwards because it opposes motion. And that's it. We don't have anything pushing the biker except for gravity, so we need to make the gravity in components. That we have a FGX, and we have a FGY as well. And a positive's direction of motion. So this guy's, I'm not going to chart the forces right now, but I'll just do yellow for positive. Of course, for some reason, I push the highlighter button and it doesn't do anything. That's positive. That's positive. And then I'll do what opposes the motion. That. Well, that doesn't, the gravity doesn't oppose the motion, but whatever. It's just because normal force is positive, right? So then we're trying to find specifically the gravity, or the friction. So the friction is in the X, so we only use the X forces, and I'll circle those. This is an X thing, this is an X thing, so we only use those. This is negative, so negative F plus FGX equals MA. So then we have negative this, and then we have MA minus FGX. And I'm going to rewrite that as MG sine theta, because you might say, hey, I thought that X meant cosine. Well, not this time, because the surface is, and you would just have to know your trigonometry, but for this, the surface is in terms of because let me try to explain this quickly. We have FG, and if we're trying to find the X component, that would be sine, because sine is adjacent, and this is adjacent to the FG. Why usually it's cosine is because usually we're doing something that's horizontal, but FG is vertical. So remember that, it's opposite of what you think. So negative F is, let's plug in what numbers we have. The mass is 65. The acceleration is 2.3 minus the mass is 65. The gravity is 10 times sine of the angle, which is 6. You plug all of that dumb stuff in, and you get negative 85.5 newtons, but the F, this is already negative, so you switch it around, and that is this. And there you go, that is how you do a problem with an incline. So things that are sometimes that I didn't explain as well at the beginning for the background information is that tension forces are the same thing if it's the same rope. And for inclines, FGX will use sine, not cosine. And there you go. That will be it for this video on dynamics. Thank you for watching, and that'll be it.